Hello friends, today we are going to discuss about linear wave shaping networks using RC elements. There are basically two types of linear wave shaping networks are possible with RC elements. They are RC high pass filter and RC low pass filter. First of all, we will analyze the RC low pass filter and its response to square wave input. Okay friends, so let's start. For RC low pass filter, you need a resistor, capacitor, a voltage source and a voltmeter. Now construct the circuit. Yes. Okay. Right friends, the simple RC low pass filter is constructed. As we know, the here for sinusoidal input we will discuss the output. We will observe the output, how it changes. Here the time period or the time constant of the circuit is RC, which is tau. Tau equals to RC. That means 1 kilo ohm into 1 microfarad, which is 1 millisecond. And the time period of the input signal is sine wave at 1 kilohertz. That means it is also of the same time period as that of the time constant, which is 1 millisecond. So let's see how the input and output varies. This is the input and that is the output. Yes, there is a phase shift here. And friends, we got a phase shift. Okay friends, now as I applied the input voltage of 10 volts, the resultant output voltage is 1.56 volts and minimum 1.83 volts. (1.57 to 1.57 volts). As we know that the cutoff frequency of RC low pass filter is 1 by 2 pi RC, where RC is 1 millisecond. So 1 by 2 pi into 1 millisecond, which is approximately 159 Hz. So whenever we applied 159 Hz frequency, then the output will be 70.7% of the applied input amplitude, applied input amplitude. 150, yes, 156, 789. Right, right. Oh, what is the output? Yes, 7.1 7.07, 7.07. Right, friends? Thus, we can know, we can say that the cutoff frequency of a low pass filter is 1 by 2 pi RC. If we applied a square wave, then what will happen? Square wave time period will be 1 millisecond, okay, and peak to peak voltage will be 10 minus 10 volts. Width of the pulse will be 50 and the rise time will be set it to 0 and fall time to 0, and there is no delay. Then let's observe the low pass filter output. See, friends, a little curvature is observed here at this point, from here to there, like here. Whenever the applied input voltage is greater than, okay, the applied input voltage or the applied input frequency, the applied input frequency is greater than the time period, time constant. Here the time constant is 1 millisecond and the applied frequency is 1 millisecond. If the time constant is less than time period, then what will be the output? Let's see how the output changes. See, friends, it is a semi bent accord at each corner. If the time period is far less than time constant, then see how the input changes. Let's see the output. It's really a triangle signal with very low amplitude of 500 millivolts peak to peak. In this way, friends, the low pass RC circuit acts as an integrator. Whenever the time constant is far greater than time period of the applied square wave or applied input, then only the low pass filter will act as a integrator. Now let's see how the square wave affects high pass filter. Okay, friends, the simple high pass filter, if we take the output voltage across resistor, then it will be high pass. If we take the output across capacitor, then it will be low pass filter of a RC series circuit. Hence, and this waveform is when the applied input is of high frequency when compared with the time constant, 10 kilohertz frequency along with time constant. But it will be so as it is going to be stabilized. Yes, 10 to 10 volts. So applied input is as it is the reproduction of the output is the reproduction of the input. Friends, suppose if we applied the frequency which is equal with the time constant, frequency of time constant, then the output will be appear like this. Thus the differentiation is going to be happening. If the time period is far greater than time constant, then what will happen? The impulses will be developed. Well, friends, impulses of 7.5 volts was going to be developed. That means if we applied a 10 volts input, then the output voltage was going to be developed as 7.5 volts impulses. If we saw the voltage across capacitor, here, and this is the case when the time constant is far smaller than the applied time period of the square wave. Here the green waveform was the output of integrator and the blue waveform was the output of differentiator. That means low pass filter and high pass filter respectively. Now let us equate the time constant and the time period of the applied input wave, that is 1 millisecond. Then observe the output of integrator, which is in green, and the differentiator, which is in blue, are the low pass filter in green and the high pass filter in blue. A small curvature in green and a small tilt in blue. And whenever the time period is far or smaller than the time constant. Then observe that. And in this case, the time constant is far greater than the time period of the applied input voltage. Approximately. The applied input is reproduction of the as it is the reproduced, and this is the output of the low pass filter. Thanks for watching, friends. Please subscribe with us for more updates.